Hello everyone, this is Dr. K. Aguilan, Department of Mathematics, St. Joseph College of Engineering, OMR Chennai. Today I am going to start the problem as Gram-Schmidt process to transform the basis, which means we have an inner product space. From that inner product space, we apply the Gram-Schmidt process to transform the basis and also to find the orthogonal basis. Okay, so this is the problem. Let the vector space P2 have the inner product of P comma Q equal to integral -1 to 1 P of X, Q of X dx. Apply the Gram-Schmidt process to transform the basis S, which is equal to U1, U2, U3, which is equal to 1 x, x square into an orthonormal basis. We already discussed about how to find the orthogonal process using Gram-Schmidt method. So we have a formula for U1, you have a formula for U1, U2, U3, and also we have a formula for orthogonal basis W1, W2, W3, right? So we just recall the process from the previous video, and also here we proceed the results. So let U1 equal to 1, U2 equal to x, U3 equal to x square. Where from the basis U1, U2, U3, which is nothing but 1, x square. From this, we can consider U1, U2, U3, right? So next, here also given polynomial. P2 is nothing but polynomial. So 1 is a polynomial, x is a polynomial, and x square also a polynomial. And inner product of P comma Q also given. This is nothing but integral -1 to 1 P of x, Q of x into dx. Well, so now we need to find V1, V2, V3. So, or else we can consider as this where 1, x square also we can consider as U1, U2, U3. We can find V1, V2, V3. Or else we can consider this one is V1, V2, V3, and also we can find the U1, U2, U3. This is the same. That's the parameters only. So first one is V1 is nothing but U1 equal to 1. V2 is nothing but U2 minus inner product of U2 comma V1 divided by norm of V1 square into V1. Now, we can find the inner product of U2 comma V1, and also we should find inner norm of V1 square, and then we substitute these values into this term, we can find the V2 value. Similarly, we need to find V3. V3 also we have formula. V3 also we have formula U3. See, for the last video, we just considered U1, U2, U3 for the using formula. Here, just replaced by wherever U occurs, we replaced by V. Simple. Okay. Similarly, we need to find the parameters of U3, inner product of U3 comma V2, norm of V2 square, inner product of U3 comma V1, norm of V1 square. Substitute all these values and we can get the V3 value. So similarly, we need to find orthonormal basis W1, W2, W3. For the previous video, we substitute U1 divided by norm of U1, U2 divided by norm of U2. Here we considered V1, V2, V3 we need to find. So that here we replaced by V1, V2, V3. Simple. This next problem is the same. So for the previous problem, we just considered the vectors. But here the vectors are given in the format of polynomial. Right. So, okay. So first V1 is nothing but U1, which is nothing but 1, first term, right? 1 second. So this is V1. This is U2. Sorry, this is U1. This is U2. This is U3. Right. Okay. So, 1 second. Fine. Next, consider from the given question, we can write this is the polynomial format for this problem. And U1 is nothing but V1 equal to 1. V2 is nothing but we have a formula. So Substitute these terms into this formula, we can get V2, right? So next we need to find inner product of V2 comma U2 comma V1. So what is U2? U2 is nothing but X, right? U2 is nothing but X and V1 is nothing but U1. V1 equal to U1 equal to 1. So V1 is nothing but U1. U1 is nothing but 1. Substitute these two values into this format. So for the previous problem, we just apply the vectors in this vectors, the inner product of that vector, right? But here we need to substitute in the format of integral -1 to 1 P of x Q of x into dx. P of x is nothing but U1. Q of x is nothing but V2. That means the two terms. So sub integral -1 to 1 P of x. What is first term is P of x, right? So here P of x equal to U2. U2 equal to x. And then Q of x equal to V1. V1 is nothing but U1. U1 is nothing but 1. So substitute here the simple integration only. So x into 1 equal to x, integral -1 to 1, x into dx. So integration of x is nothing but x squared by 2, right? Integration of x is x. Integration of x. Integration of x. Sorry. So the integration of x dx equal to this term. X square x by 2. Okay, fine. Fine. So next, so integration of x dx is nothing but x square dx. So substitute the lower limit and upper limit. So 1 by 2, take it as common and substitute upper limit minus lower limit. So what will be the remaining? Which is equal to 1 by 2. So 1 by 2 common. So we just take it out. And then what will be the balance? X square minus 1, which means a lower limit, and then upper limit. So substitute the upper limit and lower limit. 1 by 2 into upper limit is nothing but 1. 1 square equal to 1 minus 1. So whole square equal to 1. So minus lower limit minus 1 whole square equal to plus 1. So 1 minus 1 equal to 0. So answer will be 0. Okay. So V2 is we found. So then what will be, we can consider, okay, norm of V1 square. What is norm of V1 square? For the last problem, norm of V1 square is nothing but inner product of V1 comma V1, right? But here, V was same, V1 comma V1. So integral minus, why we consider this term? Because here, inner product of P comma Q is represented as this term. That's why we are considered this format. So inner product of V1 is nothing but V1 comma inner product of V1 norm of V1 square is nothing but inner product of V1 comma V1. So here P of x equal to V1, Q of x equal to V1. So what is V1? V1 is nothing but 1, which means U1. U1 is nothing but V1. V1 is nothing but 1. So substitute integral -1 to 1. 1 into 1 into dx. So integral dx is nothing but x. Integral dx is nothing but x. So upper limit, lower limit, substitute upper limit minus, substitute lower limit, minus of -1, right? Substitute upper limit 1 minus of, substitute lower limit minus 1. So what will be the answer? Answer is 2, right? So equal to 1 plus 1 equal to 2. So the simple mathematics only. So 1 plus 1 equal to 2, right? Okay, fine. So next term is V3. We have a formula. We have a formula for this V3, right? Sorry. 1 second. We have a formula. Okay, so we have a formula. So substitute these parameters in this formula, then we can get the V3 value, right? So what is U3? U3 is nothing but x square, x cube. And also V2. What is V2? V2 already we found 0. And then when we substitute V2 value 0 here, this whole term will be vanished, right? So when we apply V2 equal to 0 here, this whole term will be vanished. So balance term U3 minus this term only. So what is V1? V1 is nothing but norm of V1 square is nothing but 2. What is V1? V1 is nothing but U1. U1 is nothing but 1. So substitute. So we need to find only this term. Understand? So inner product of U3 comma V1. This term is going to be 0 vanished. So, but still they find inner product of U2 comma U3. So okay. So okay, first this term, inner product of U3 comma V2. What is U3? U3 is x square, right? So V2, what is V2? V2 is 0. What is V2? V2 is, wait 1 second. V2 is 0, right? No. U3 is x square. V2 is 0. Actually, V2 is 0. Here the problem. V2 is 0. So the whole term will be vanished. Then, no, V2. So this term only vanished, sorry. This term only vanished, right? This term only vanished. What is V2? U2 is V2, x. U2 is x, right. U2 is x. So we need to find this term. So x cube integral minus 1 to 1 x cube dx. So x cube means x power 4 divided by 4, integration of x cubic x power 4 by 4. So substitute my lower limit, upper limit. We can get 1 by 4, the common 1 by 4 take it outside. So x power 4, upper limit is 1 minus lower limit of minus 1 power 4 is plus 1 only. So minus 1 minus into minus of plus 1 equal to 0. So this term totally is 0. And V2 square, norm of V2 square. So as V2 is nothing but x. So x into x square. Integration of dx is nothing, x square is nothing but x power 3 divided by 3. Substitute upper limit and lower limit here. We can get 2 by 3. Okay. So, and also we need to find inner product of U3 comma V1, right? U3 comma V1. So U3 comma V1 is nothing but, what is U3? U3 is nothing but x square, right? And also, what is V1? V1 is nothing but U1. U1 is nothing but 1. So this value. So multiplication of 1 into x square is nothing equal to x square. So integration of x square ds x is nothing but x power 3 divided by 3. Substitute the upper limit and lower limit here. We can get 2 by 3 value. Is it clear? So take it out 1 by 3 and also substitute x power 3. 1 power 3 is nothing but 1 and minus 1 power 3 is nothing but minus 1. So minus of minus 1. See, 1 x is 1 minus of minus 1. Okay. So 1 power 3 minus of minus 1 power 3. So 1 minus 1. 1 minus of minus 1, right? 1 minus of minus 1. So answer will be 2. Answer will be 2. Okay. So already 1 by 3 outside. So 2 into 1 by 3, which means 2 by 3. So substitute these all the values in V3 formula we can get. So what will be the first term? U3. U3 is nothing but x square, right? Okay. So substitute x square and minus what the term? Inner product of U3 comma V2. What is inner product of U3 comma V2? 0. So substitute 0 and divided by what? Norm of V2 square. So 2 by 3 and V2 is nothing but this term only vanished. So V2 is nothing but U2. What is U2? U2 is nothing but x. So substitute here x square. X only. U2 is x only. So here x only. So here x only, not x square. Here x minus inner product of u3 comma v1, inner product of u3 comma v1, it's nothing but 2 by 3. And also what is inner product of v1 square? What is v1 square? What is v1 square? We already found, right? v1 square is nothing but 2. So 2. And also what is v1? v1 is equal to u1, right? u1 is equal to u1, u1 is equal to 1. So substitute here and then we can get. So what will be the answer? This term, full term vanished. And what will be the remaining term? v3 equal to x power 3 minus 0 minus 2 by 3 divided by 2. So reciprocal 2 by 3 into 2 by 3. 2 by 3. So 2 to cancel. So 1 by 3. Right? 2 by 3 into 1 by 2. Reciprocal is 1 by 2. Okay. So minus 1 by 3. So final answer is x square minus 1. Fine. So next term. So next we need to find v3, norm of v3 square. We don't want to norm of, okay. So next term is norm of v3 square. Need to be done. This is not necessary because we already found v1, v2 and v3, right? v1, v2 and v3. Okay, v1, v2 and v3. So next, orthonormal basis. So if in case they ask what about find norm of v3 square means, again, we know the value of v3, right? v3 x square minus 1 by 3. So substitute v3 comma v3 into inner product. So inner product of p of x, q of x, p and q we have formed. So substitute this in this form, integral format, we can get this result. So simply multiply the corresponding x power 4 x square into minus x square into 1 by 3 minus x square into 1 by 3 plus 1 by 9. So after x square, x power 4 minus 2 into 2 by 3 into x square plus 1 by 9. So each term should be integrated in the separated form. So x power 4 means x power 5 by 5, lower limit, upper limit, minus 2 by 3 should be taken outside, and x square, integration of x square is nothing but x power 3 divided by 3 and lower limit, upper limit, plus 1 by 9. Here the integral dx. So it means integration of dx is nothing but x. Substitute upper limit and lower limit. So 1 by 5, take it 1 by 5 common outside. So substitute upper limit and lower limit 1 plus 1. 1 minus of minus 1 power 5 equal to minus 1. So 1 plus 1. Similarly, substitute. This is the odd function. So definitely the answer will be minus 1. So 1 minus of minus 1, 1 plus 1. Similarly, here 1 minus of minus 1 is 1. So after substitute these values, we can get and simplify the same simple method, and we can get 8 by 45. Right? Okay. So next orthonormal base is W1, W2, W3. So what will be the formula for W1, W2, and W3? V1 divided by norm of V1, V2 divided by norm of V2, V3 divided by norm of V3. We know all the formula for V1, V2, V3, right? And also we know all the values of V1, norm of V1, V2, norm of V2, V3, norm of V3, right? V1 is nothing but, so from the question itself, V1, V2, these are nothing but V1, V2. We know the value of U1, U2, U3. Here we consider as V1, V2, V3, right? So what is V1? V1 is nothing but 1. V2 is nothing but, what is V2? Yeah. V2 is nothing but, wait. What is V2? V2 is nothing but U2, right? This term vanished. So V2 is nothing but U2, which means X, only X, right? Only X. And V3 is nothing but X square minus 1 by 3. So substitute these all values here. And also we know norm of V1 square is nothing but 2, which means norm of V1 equal to square root of 2. Norm of V2 is nothing but 2 by 3, which means norm of V2 equal to square root of 2 by 3. Norm of V3 square equal to 8 by 45. That's why we found norm of V3 square here. So Then square root of 8 by 43. Substitute these values and we can get 1 by root 2, just multiplication. 1 divided by root 2 x, and final answer should be this. 1 divided by V1 is nothing but V1 is nothing but 1. Norm of V1, square root of 2, 1 by square root of root 2. So here 1 by square root of root 2 as it is. Simple mistake. And x divided by square root of 3. So yeah, into cross multiplication, then we can say that square root of 2, square root of 3 by 2, x, square root of 45 by 8, x square. Right. Similarly, the next problem, same here, the limit only changed. Previous problem only here also proceed, but the limit only changed. Here we consider the inner product of p comma q equal to integral 0 to 1. For the previous problem, minus 1 to 1, right? So here 0 to 1, simple. The same polynomials x square, x 1 into x comma x 1 comma x square. So u1 equal to x, u2 equal to x, u1 equal to 1, u2 equal to x, u3 equal to x square. So whereas v1 equal to u1 equal to 1, v2 we have a formula, the same blah blah things, and also we need to integrate and substitute the limit, upper limit and lower limit. Then the changes will be happen. Where only the limit, the changes definitely will be happen. Whereas for the last problem, minus 1 to 1, the limit the limit is minus 1 to 1, but here 0 to 1. So wherever minus 1 occur, we just replaced by 0. And integration of x is nothing but x square by 2, lower limit and upper limit. Upper limit is 1 minus lower limit is 0. So answer will be 1 by 2. The same way. And also here now should be here v1 should be fine. So norm of v1 square is nothing but inner product of v1 comma v1. So we have a format for inner product of v1 comma v1. That means first two terms equal to integral 0 to 1 p of x into q of x into dx, right? The same procedure. So apply here, and v2 equal to substitute u2 value. What is u2? u2 is equal to x. So x minus inner product of u2 comma v1. What is inner product of u2 comma v1? 1 by 2. 1 by 2 into inner product norm of v1 square. What is norm of v1 square? 1 and v1. What is v1? Into 1. Yes. So answer will be x minus 1 by 2. Right? Similarly, v3, we have a formula for v3, right? Sorry, once again. We have a formula for v3. So this is the formula. This is the formula for v3, the same formula only. So substitute the parameter values of inner product of u3 comma v2, u3 comma v1, v2, norm of v2 square, norm of v1 square, v1, v2, u3 values in this formula. We can get v3 value, right? So need to find inner product of u3 comma v2. So what is u3? 1 comma x square. So x square is a u3. What is v2? v2 we already found, x minus 1 by 2, right? So multiply these terms and finally we can get this term, right? X cube minus x square by 2, right? So integration of x3 by x power 3 is nothing but x power 4 divided by 4. Integration of x square is nothing but x power 3 divided by 3. 1 by 2, take it out the common term. So substitute upper limit and lower limit. 1 power 4 is nothing but 1. 0 power 4 is equal to 0. So 1 minus 0 equal to 1. Similarly, 1 minus 0 equal to 1. Right? So after substituting, what is the denominator should be 24. So here the multiply by 6 into 6. Here the multiplication by 4 into 4. we can get this result. Similarly, we need to find v2 square, right? Integral 0 to 1 x minus 1 by 2 into x minus 1 by 2 into dx. Integral 0 to 1 x square minus 1 by 2 into x minus 1 by 2 into x plus 1 by 4 to dx, right? Just multiply these things and finally simplify this. And integration of each term, and x square is nothing but x power 3 by 3, x is nothing but x square by 2 and 1 by 4, take it as common. Here integral dx only, so x is okay. So after substituting upper limit and lower limit, we can get this term. From this term, we can simplify this term. And also here, LCM is what will be the answer? It's 24 only. So multiply by these two first initially multiply. So 2 into 3, 2 into 2, 3 into 3, 2 minus 3 divided by 6 plus 1 by 4. Then 24 is a common factor. So 4 plus 6 minus 4 plus 6 and 24. So finally, we found the answer as 1 by 12. Similarly, the inner product of u3 comma v1. This is u3 and this is v1. A simple integration only. Final answer is 1 by 3. Okay. So this is v3. So substitute all these value into v3 formula. This is after applying the all parameters. So after simplify, x square minus x minus 1 by 2 minus 1 by 3. 12, it's cancelled. So this term, so after this, x square minus x minus plus 1 by 2 minus 1 by 3. So which means plus 1 by 3. So from this, we can find norm of v3 square, right? So which means what is v3? This term should be 2 times, right? This term the same as another term because inner product of v3 is nothing but the norm of v3 whole square is nothing but inner product of v3 comma v3. Fine. So after this multiplication and simplify the simple integrate, taking the simple integration, we can get this result, right? Okay. So from this u1, u2, u3, v1, v2, v3, norm of v1, norm of v1 square, norm of v2 square, norm of v3 square. So finally, we can conclude the orthogonal basis. So what is W1? W1 is nothing but V1 divided by norm of V1. W2 is nothing but V2 divided by norm of V2. W3 is nothing but V3 divided by norm of V3. So substitute V1, V2, V3, norm of V1, norm of V2, norm of V3. We can find the final answers, right? So these are the simple terms. So the previous class, we just apply the vectors. Here we just apply the polynomial terms into the inner product of p comma q, but integral form, right? So this is one of the most important concept in engineering mathematics. And hope you all understand this concept. Okay. Thank you.